Hello everyone. In this video, we will be discussing about the alpha-beta pruning technique. Alpha-beta pruning, it's an advanced version of min-max algorithm. The drawbacks of min-max, it explores each node in the tree deeply to provide the best path among all the paths. It increases time complexity. Alpha-beta pruning, it overcomes the drawback by less exploring the nodes of search tree. Alpha-beta pruning. It cut off the search by exploring less number of nodes. It makes same moves as min-max algorithm, but it prunes the unwanted branches using the pruning techniques. There are two threshold values, say alpha and beta. Alpha is the best highest value a max player can have. It is the lower bound which is representing the negative infinity value. Beta is the best lowest value a min player can have. It is the upper bound which represents the positive infinity. Each max node has alpha value which will not decrease, and each min node has beta value which will never increase. Alpha beta pruning technique can be applied to trees of any depth, and it is possible to prune the entire subtrees easily. Let us consider a game tree, say, where P and Q are two players. The game will be played alternatively, chance by chance. For example, P be the player who will try to win the game by maximizing its winning chances. Q is the player who will try to minimize P's winning chances. So alpha representing the maximum value of the nodes, that will be the value of P. Beta will represent the minimum value of the nodes, which will be the value of Q. Beta cutoff pruning, beta pruning, which is happening at min nodes. So if a minimum node beta receives a value less than or equal to the current alpha of its parent max node, the remaining branches are pruned. So beta less than or equal to alpha. So since minimum nodes always pick the lowest value and we already found a value less than or equal to alpha, exploring further would only make it smaller or the same, which is not going to affect the parent max node. Alpha cutoff or alpha pruning, which is happening at max nodes. If a max node alpha receives a value greater than or equal to the current beta of its parent min node, the remaining branches are pruned. Alpha greater than or equal to beta. Since max nodes always pick the highest value and we already found a value greater than or equal to beta, exploring further would only make it larger or the same, which does not affect the parent min node. So from this beta cutoff and alpha cutoff, as you could see, both are the same. Beta less than or equal to alpha is the beta cutoff and alpha greater than or equal to beta is the alpha cutoff. So which means both together we can make it as a single equation, alpha greater than or equal to beta. So this could be checked both at the max as well as the minimum node. Let us see how the alpha beta pruning works. We'll start with the max player. So we'll start with node A here, and the values of alpha and beta are minus infinity and plus infinity. So the same alpha beta values will be passed on to node B. The same values will be passed on to the node D as well. So here in node D, we need to calculate the value of alpha. It's because node D is going to be the max node. So it will update the alpha value. Node D will update the alpha value. This alpha is compared at first with this node 2 and then with node 3. So max of 2 and 3 is 3. Now this will be the value of alpha here. Also, the node value of D will also be 3. Now after this, it backtracks to node B. Here node B is the minimum node. So beta value will get updated. It is the turn of this minimum player to update the beta value. So minimum of infinity and 3 is going to be 3. So this beta gets updated to 3. So at node B, alpha is minus infinity and beta is 3. The next step, the algorithm, it traverses to the next successor of node B, that is E. The same values minus infinity and 3 will be passed on to node E. Now at node E, this is the turn of the max player. So here the value of alpha is going to change. This current value will be compared with 5. So max of minus infinity and 5 will be 5. So this gets updated to 5. So at node E, alpha is 5 and beta is 3, which means alpha is greater than or equal to beta, the condition is satisfied. Alpha greater than or equal to beta is satisfied. So the right successor of this E will be pruned. The algorithm will not traverse here. So the node value of E will be 5. In the next step, we backtrack here and from node B to node A. And in node A, the value of alpha will be changed. That is, the alpha will be updated. It is the turn of the max player. So it's going to apply max function. Max of this minus infinity and 3 will be 3. So this alpha value, it gets updated to 3. So alpha is 3 and beta is infinity. So this is at node A. Now what happens here is this alpha 3 and beta infinity, the two values are passed on to the right successor of A, that is to node C, here, node C. Now at node C, alpha is 3 and beta is infinity. The same values will be passed on to node F also. Here in node F, again it's a max player, so it has to update the alpha value. This alpha will be compared with the left child of node F, that is 0. So max of 3 and 0 is going to be 3. Then you compare it with the right child 1. Again max of 3 and 1 is 3. So alpha still remains as 3 only. But the node value of F will become 1. The node value will become 1 because it's a max, so it checks the max of the values, it's 1. Now node F will return this node value to node C here. Now at node C, which is the minimum node, alpha is 3. Here it has to update beta, which means it's minimum of this infinity and 1, which is 1. So this beta gets updated to 1. So at node C, alpha will be 3 and beta is 1. So again here it satisfies the condition alpha greater than or equal to beta. The condition is satisfied. 3 is greater than or equal to 1. It's true. In this case, the next child of C, so the node G will be pruned. It will not compute the entire subtree, that is G. Now C, node C will return the value of, say, 1 to this node A. Here it's a max node, so which is going to apply the max function. So max of 3 and 1 will be 3. So the optimal value for this maximizer in the given example is going to be 3. Here this is representing the optimal path chosen by the min-max algorithm after applying the alpha beta pruning, which means The nodes along the red path are the ones that contribute to the final min-max decision at the root node A. Thank you.